All right, number 34. Number 34, we have an inclined plane with two blocks, block A and block B. They're connected by a rope. The coefficient of friction here is 0.10 for block B and 0.20 for block A. Block B has twice the mass of block A. We want to figure out what the tension in the string is between the two. So we're going to do the same thing we always do. First we're going to do a free body diagram. We have to have two. One free body diagram for block A, one for block B. So for block A, this is block A's free body diagram. This is MAG. We have a normal force going this way. We have tension going this way. And we have friction going this way. Okay. Now, be careful. Our motion is going to be this way. But we usually draw our inclined planes the other way. So in this case, the inclined plane this way, so our angle here, theta, this angle, has to be over here. So then when I take the components of gravity, this is MAG cosine theta on this side. On this side, this is MAG sine theta. Okay, so same thing for part B, or for block B. We have to draw our free body diagram. We have, all right, crazy here, MBG going down. We have normal force coming off this way. We have tension going this way. Try to make it the same length here. Tension going this way. And we have friction going this way. Kinetic friction going that way. Okay? So, those are the only forces acting on it, but we have to again do the same thing. We have to make our coordinate system, and then our angle here, theta, is here, so this is going to be up here, this is going to be MBG sine of theta. And then down here, this is going to be MBG cosine theta. And this is normal A, this is normal B. Remember, they're not the same. If you have the same thing in two different places, you have to subscript them because they're not the same. The normal forces are not the same. Now tension I don't, because the tension is the same in both of these. All right, and the friction is different too. So this is friction FKA, this is FKB, so those should be different. Okay, so here we go. What we need to do is we want to find the tension, so we got to start solving this. We're going to use F net x for block A. So we got F net x is equal to, and we have, and positive is this way, so we got T plus MAG sine of theta minus the friction force. This is equal to MA times its acceleration A. It's equal to the tension plus MAG sine theta minus mu sub k times the normal force. Well, the normal force here, if I do F net y over here, is going to be the normal force on A is equal to, or minus MAG cosine theta, or the normal force is MAG cosine theta. So I'm just going to plug that back in here for the normal force, so this is MAG cosine theta. And my pen is dying on me. All right, so I don't know T, I don't know A, I can't solve that. So let's go to block B. So block B, I'm going to do F net x. And F net x is going to be equal to, positive is still the same direction because they're both going the same direction, so positive is still this way. mBg sine theta minus tension minus the friction force. And this has to be equal to mb times its acceleration. This is mu sub k times F net, so let's do F net y. So we can get the normal force minus mBg cosine theta. Or this is equal to 0, so the normal force is equal to mBg cosine theta. So this is going to go into here, so this is going to be mBg cosine theta. All right, I know mBg, Ig, I know that, I don't know t, and I don't know a. So I got two equations and two unknowns. So we need to solve that. You can solve this multiple ways. I'm going to do it this way. The easiest way I think to do this is solve this for t up here and then plug it into here. Now the algebra is a little trickier. You got to be real careful not to make a mistake. But if I solve this for t, I'm going to move all this to the other side. So I'm going to get t is going to be equal to ma times its acceleration minus mag sine theta plus mu sub k mag cosine theta. So all I did was move that to this side and this to this side. Change their signs. Now I'm going to plug that back into there. So MBA is equal to MBG sine theta minus, now we got to be careful because it's minus and it's minus everything, so I have to change the sign of every term here. So this becomes minus MA times its acceleration plus MAG sine of theta minus mu sub k MAG cosine theta, that's just t, minus mu sub k MBG cosine theta. Hopefully I'm still on the screen. I think so. All right, so I got this big long equation, and I'm going to solve it for the acceleration. So I'm going to solve it for the acceleration, so I have to move that to this side, so I'm going to end up with MBA plus MAA is equal to this whole thing again. So MBG sine theta plus MAG sine theta minus mu sub k MAG cosine theta minus mu sub k MBG cosine theta. All right, then I factor out the a and I divide by all that. So I'm going to get a is equal to MBG sine theta plus MAG sine theta minus mu sub k MAG cosine theta minus mu sub k MBG cosine theta all over MB plus MA. All right, at this point I like to analyze it and make sure we didn't make a mistake. If you look here, this term, MBG sine theta, is gravity trying to pull block B down. This is gravity trying to pull block A down. So both those are pulling it down. But they're getting opposed by the friction force on block A and the friction force on block B. Now I got to be careful here. I got a little sloppy. Remember, these are not the same friction forces. So be careful on that. The coefficient is different. So this is coefficient A, this is coefficient B. Okay? Because if you put the same number in there, you're going to get in trouble because you see these are different. So this should be mu Ka, mu Kb. All right, now I have all those numbers though, so I can just plug all this in to figure out what what the value is. So MB is 2, so this is 2 times 9.8 times the sine of 20 plus 1 times 9.8 times the sine of 20 minus, and the first one is 0.2 times 1 times 9.8 times the cosine of 20 minus 0.2. Oh, I did that wrong. This is m sub a. This is point, no, that's 0.2. M sub b is 0.1. So this is 0.1 times 2 times 9.8 times the cosine of 20. All that divided by 2 plus 1. All that was to get the acceleration. And if you did it right, you get an acceleration of 2.12 meters per second squared. But after all that work, you're like, oh no, that's not what they asked for. What they asked for was the tension. But now, since I have A, I can solve for the tension. I'm just going to use this equation because I already have it solved for T. So I'm just going to plug that into there. I'm going to say, oh, well, T then is equal to MA, which is 1 times 2.12, minus, so if you're lost, this is coming from here, minus 1 times 9.8 times the sine of 20, plus u sub Ka, which is 0.2 times 1 times 9.8 times the cosine 20. All that will give us the tension. And if you do all that, you get a tension of 0.61 newtons. And that is the answer to the problem.